All right, good morning, class. My name is Malik Moore. Today I'll be discussing autonomous cars. First off, does anybody know the actual definition of an autonomous car?
Car that drives itself?
Yeah, pretty much. That's it. But to give the exact definition, it's also known as a driverless car, self-driving car, or a robotic car. It is an automated or autonomous vehicle capable of fulfilling the main transportation capabilities of a traditional car. The autonomous means having the power of self-government. Many historical projects related to the vehicle anatomy have in fact only been automated due to a heavy reliance on artificial hints in their environment, such as magnetic strips. Autonomous control implies good performance under significant uncertainties in the environment for extended periods of time and the ability to compensate for system failures without external intervention. As can be seen from many projects mentioned, it is often suggested to extend the capabilities of an autonomous car by implementing communication networks both in the immediate vicinity for collision avoidance, also for congestion management, and by bringing in these outside influences in the decision process, some would no longer regard the car's behavior or capabilities as autonomous. In an article by an author named Wood, the article generally uses the term autonomous instead of the term automated. We have chosen this term autonomous because it is a term that is currently in more widespread use, and however the term is arguably more accurate. Now, we're going to discuss a little bit of the history of autonomous vehicles. Experiments have been conducted on automating cars since at least the 1920s. Promising trials took place in the 1950s, and work has proceeded since then. And this is actually the RRL's modified 1960 Citroen DS19 that's at the Science Museum in London. It's one of the first, the early first autonomous vehicles. The first self-sufficient and truly autonomous cars appeared in the 1980s with Carnegie Mellon University's NAV Lab and ALV projects in 1984 and Mercedes-Benz in 1987. And I have a quick video for you all.
The Mellon NAV Lab project brings together computer vision, advanced sensors, high-speed processors, planning, and control to build robot vehicles that drive themselves on roads and cross-country. The project began in 1984 as part of ARPA's Autonomous Land Vehicle Program, the ALV. In the early 80s, most robots were small, slow, indoor vehicles tethered to big computers. The Stanford cart took 15 minutes to map obstacles, plan a path, and move each meter. The CMU Imp and Neptune improved on the cart's top speed, but still moved in short bursts separated by long periods of looking and thinking. In contrast, ARPA's 10-year goals for the ALV were to achieve 80 kilometers per hour on roads and to travel long distances across open terrain. With the Terragator, our first outdoor robot at CMU, we began to make fundamental changes in our approach. Instead of move and stop driving, the Terragator kept moving continuously. Instead of processing individual images in isolation, the Terragator processed image streams. New sensors such as scanning laser rangefinders gave it capabilities for finding landmarks, avoiding obstacles, and driving in rugged terrain. But it could do only one thing at a time at a top speed of a few centimeters per second. The NAV Lab, built in 1986, was our first self-contained test bed. It had room for onboard generators, onboard sensors, onboard computers, and, most importantly, onboard graduate students. Researchers riding on board were in a much better position to observe its behaviors and to debug or modify the programs. They were also highly motivated to get things working correctly. The latest test bed is the NavLab 2, an Army ambulance Humvee. It has many of the sensors used on earlier vehicles, plus cameras on pan tilt mounts, and 3 aligned cameras for trinocular stereo vision. The Humvee has high ground clearance for driving on rough terrain and 110 km/h top speed for highway driving. Computer-controlled motors turn the steering wheel and control the brake and throttle. Perception and planning capabilities have evolved with the vehicles. Alvin is the current main road following vision system. Alvin is a neural network which learns to drive by watching a human driver. Using back propagation, Alvin takes about 2 minutes to learn how to drive on a new type of road. 10 times a second, Alvin digitizes a new image, propagates it through its network, and outputs both the steering direction and a confidence. Alvin can run several nets simultaneously and automatically switches from net to net as the road type changes. Alvin has driven as far as 100 kilometers and at speeds over 110 kilometers per hour.
All right, and so now we get into the actual confusion. Some people said there's a big advantage to it, and some people said there's a disadvantage to it. And part of it is if fully autonomous cars become commercially available, they have the potential to be a disruptive innovation with major implications for the society. And the likelihood of widespread adoption is still unclear, but if they are used on a wide variety, policymakers face a number of unresolved questions about their effects. One fundamental question is about their effort on travel behavior. Some people believe that they will increase car ownership and car use because it will become easier to use them and they will have ultimately be more useful. They may in turn encourage the urban sprawl and ultimately total private vehicle use. Others argue that it will become easier to share cars and thus it will discourage outright ownership and decrease total usage and make cars become efficient forms of transportation in the relation to the present situation. Also in June, as the end of 2013, 4 U.S. states have passed the law where they can pretty much use the autonomous vehicles on open roadways, and that's Nevada, Florida, California, and Michigan. And in 2011, the Nevada legislature passed a law to authorize the use of autonomous cars. Nevada thus became the first jurisdiction in the world where autonomous vehicles might be legally operated on public roads. Also in 2013, the government of the United Kingdom permitted the testing of autonomous cars on public roads. Prior to this, all testing of robotic vehicles in the UK had been conducted on private property. In 2014, the government of France announced the testing of autonomous cars on public roads would be allowed in 2015. And they'll have about 2,000 kilometers of road that will be open for the national territory. Individual vehicles may benefit from information obtained from other vehicles in the vicinity, especially information related to traffic congestion and safety hazards. Vehicular communication systems use vehicles and roadside units as the communicating nodes in a peer-to-peer network, providing each other with information. As a cooperative approach, vehicular communication systems allow all cooperating vehicles to be more effective. According to a 2010 study by National Highway Traffic Safety Administration, vehicular communication systems could help avoid up to 81% of all traffic accidents. Also in 2012, computer scientists at the University of Texas in Austin began developing smart intersections designed for autonomous cars. The intersections will have no traffic lights and no stop signs, instead using computer programs that will communicate directly with cars on the road. Through the implementation of global positioning systems, which is the GPS navigation of the autonomous vehicles, is simplified. The location of the vehicle can also be acquired by the longitude and latitude obtained by the GPS. In the United States, the National Highway Traffic Safety Administration has established an official classification system which has 4 different levels. And level 0, it starts at level 0. Level 0, the driver completely controls the vehicle at all times. Level 1, individual vehicle controls are automated, such as electronic stability control or atomic braking. Level 2, at least 2 controls can be automated in unison, such as adaptive cruise control in combination with lane keeping. Level 3, the driver can fully code control of all safety critical functions in certain conditions. The car senses when conditions require the driver to retake control and provides a sufficiently comfortable transition time for the driver to do so. And finally, level 4, the vehicle performs all safety critical functions for the entire trip, with the driver not expected to control the vehicle at any time, as this vehicle will control all functions from start to stop, including all parking functions. It could include unoccupied cars. And we're just going to go over some of the advantages to having autonomous vehicles. There will be fewer traffic collisions due to an autonomous system, increased reliability and fast reaction time compared to human drivers. There will also be reduction in the need for traffic police, reduction in car theft due to vehicle self-awareness, reduction of physical road signage, and also the relief of vehicle occupants for driving and navigational chores. And I have a video for you for some of the safety features.
Center where Ford will be down here to show off their latest safety technology, autonomous technology, things like, well, cars that park themselves, cars that avoid accidents, and of course cars that know where the lane lines are. And all that fun stuff is coming up next on the Fast Lane Car. Alright, so I am in the brand new Ford division with 3 other journalists, and what are your names? Nick who's with Ford, and we're here at Ford's test track in Dearborn, Michigan. Say hi, guys. That's Jill and Tim back there. And we're kind of checking out Ford's technology, specifically their kind of adaptive cruise control at this point. Now, I've been in cars equipped with this technology, and the one little flying ointment that I found is if you've got the distance set too far, people keep pulling in front of you, and you're kind of, especially if you're in traffic, you're kind of moving backwards. And so it's nice to be able to be relatively close. Obviously on the open highway, it doesn't look bad. Now the speedometer says 120, will it work up to 120? Yeah, we tried. Oh, come on, yeah, what fun is that? Yeah, that would be a cool video, 120 miles an hour at adaptive cruise control. Yeah. So everybody just speed up a little bit. Oh, no, you're not going to do it, huh? I tried, guys, I really tried. I feel, look at that. It's turning the car, no hands. How long will it do that before it stops? Oh, right there. This is what the Ford test track looks like. And there is the control dashboard so you can see what's happening. Once again, it's found the line, so I'm gonna let go of the wheel and it's gonna just go right across. All right, it did vibrate the wheel that time, so it did tell me that there's a car in front of us, so I'm gonna be more careful. Yeah, it's pretty cool technology. I mean, it's one step toward an autonomous car. So basically, if you were to activate both the proximity distance control and this feature, at some point you can let the car sort of kind of drive itself until it would stop. It will turn itself off, right? Sort of, kind of, yeah.
I'm going to show you rear end collision avoidance. Rear end means you are driving in your own lane and then you have maybe a slow moving vehicle in your own path or maybe a stationary vehicle in your own path. And then you are driving still towards the object. Because of whatever reason, you are not reacting that there is a slow moving vehicle. And then the system will give you a vibrating gas pedal. That means without knowing your co-passenger, you get the alert. It's like a silent alert.
So if there's a rear seat passenger like me, they don't know that you maybe are about to hit a car. That's why you're using the vibrating pedals.
Yeah, but that one they give it a bit early. That you still have because the purpose of the warning is designed like that. You can take over the control of the vehicle.
Then what happens next?
Yeah, and
All right, that's very informative, but not too exciting. So we'll just speed through that. And now some of the potential obstacles with having these autonomous vehicles would be the loss of privacy, the loss of driving-related jobs, drivers being inexperienced if situations arose requiring manual driving, the liability for damage, and software reliability as well. Also, in 2014, the U.S. telephone survey by Insurance.com, over 3/4 of licensed drivers said that they would at least consider buying a self-driving car, rising to 86% if car insurance were cheaper. 31.7% said that they would not continue to drive once an autonomous car was available instead. And we have some predictions on what the autonomous vehicles will bring in the future. So by 2016, Mercedes plans to introduce Autobahn Pilot, aka Highway Pilot. The system allows hands-free highway driving with autonomous overtaking of other vehicles. So, that'll work if you're late to school, late to work, just take control, get them out the way. We get there on time. Also, by 2020, Volvo envisions having cars in which passengers will be immune from injuries. Volvo also claims vehicles will be crash-free. By 2025, most new GM vehicles will have automated driving functions as well as vehicle-to-vehicle communication technology. And by 2040, expert members of the Institute of Electrical and Electronic Engineers have estimated that up to 75% of all vehicles will be autonomous. And so I have a brief video about the future of the autonomous vehicles.
And ahead of Mercedes-Benz cars, it says the future of driving is near.
This is a prototype which works, so none of this is fake, it's working, and this will be reality in the showroom next decade.
So Bill Lowe took this high-tech car out for a ride.
Mercedes calls it luxury in motion, the F-015, unlike any car you've ever seen.
Mercedes believes in the future, your car is not simply a place to go from point A to point B, but a chance for you to turn around and talk with others in the car in a way we haven't done in the past. What were you shooting for?
Well, our relationship with the automobile is really fundamentally changed.
This is an electric, autonomous drive car with 26-inch wheels and windows coated with a special pattern to add privacy.
It feels open. That was the whole idea.
Exactly. Again, another way to think about the luxury. Luxury is space. Luxury is comfort.
It also has touchscreen doors, so each person in the car can surf the web, email others, or look at what's around their car thanks to cameras offering 360-degree views.
In this case, you can imagine I'm seeing what another person, another car up ahead is seeing. Oh, hey, I can talk to my friend and say, you gotta see this. And he can actually see it.
And you can see what's around your F015 even when you're not with it.
So the app makes you to be connected to your car, to your autonomous car all the time. So for example, when you park the car, you want to know where it is. You click the 360-degree view and you can swipe through it and can always see where your car is parked, for example. Or when your car is driving to pick you up, you can see where the car right now is driving.
So you can always, in essence, you can watch your car at all times.
That's true, yes.
In the future, Mercedes is considering gesture controls and even more connectivity. Some of it will likely come through a touchscreen table that pops up between seats.
It's a lounge that I'm taking with me that's supposed to be moving on.
Phil Lamone, Nightly Business Report, Valley of Fire, Nevada.
All right, and that concludes my presentation. Any questions? All right.
Every day, we at Trivago run hundreds of tests to optimize for users.